Hi grade 9s, this week we are going to be taking our knowledge from last week's basic circuits and upping it to how that works with series and parallels, as well as a little bit of a deeper dive into all the different parts of our circuits. So what do you remember from last week's basic circuits? Hopefully you remember that there's four major parts. You have your wire or your conductor that allows the electricity to flow through it. You have to have a power source like a battery or a plug-in to a wall. You need to have a load. So that's somewhere where you convert energy from one type to another. And then you need to have your switch, which turns it on and turns it off. So this is one of my favorite diagrams here, and I'm just gonna move myself out of the way. So what I love about this diagram is I think that this really sums up how a circuit works. So your circuit works by this voltage or your battery pushing the flow of electrons through. Now, as the flow of electrons tries to go through the wire, there's these big areas here, but then there's your resistor, which is kind of like it just squeezes in and makes it really hard for that current to flow through your resistor. And that current flowing through is what changes our energy from one form to the other. So this, for me, is one of my favorite diagrams showing the push from our voltage onto the current or our electrons going through, and then the prevention of movement or slowing it down by the resistors here with our lasso rope around. So I'm going to let you watch this later. Conductors and insulators. So we've already talked about conductors and insulators before as to a conductor allows the electrons to flow through it easily, and insulators, you can still charge them, but it doesn't move the charge away from the spot where you put it. So here is kind of a nice visual diagram as to how that works. So insulators, they hold their electrons really close to themselves. You don't really want to give them away. They're pretty tightly bonded. Whereas in a conductor, you have free flow of electrons all over the place. But when you put a current through it, all of those electrons start moving in a uniform direction through your wire, through the circuit. Now, voltage or current, which one's more deadly? So I think that you already know that if you have a high voltage, it's much more likely to harm you than a low voltage. So 50,000 volts is going to kill you or have a much more likelihood of killing you than 10 volts. So there's another thing though. The shock can also depend on your current or your amps. So when you have a high amp, so lots of electrons flowing through, the shock is actually more deadly because you have more things going through your body. So if you have 0.001 amps pass through your body, you're not really going to feel it. So when I was doing the current and like shocking myself with the Van de Graaff generator, because it's quick, it's not very much, it doesn't really hurt very much. But currents that are in the range of even just 0.15 to 0.20 can be quite painful and can impair our muscle control because our muscles, opening and closing, contracting and relaxing, is actually also controlled by electricity. So when that happens, you can have a contraction where you now cannot let go of that live wire. And that's one of the reasons why it's so dangerous, because you can't get away from that current because your muscles will contract and you can't physically let go. So let's look at each part of the circuit on its own. So we'll start with our resistors or the resistance. And so resistors are measured with the symbol R in our formula and in the unit of ohms. So ohms, this lovely little horseshoe thing, I love drawing it, it's amazing, is actually the Greek symbol for omega. You use an ohm meter to measure it, and it was actually named in honor of George Ohm, who discovered the relationships that we've seen so far. Also, he came up with the math formula. So if you really hate math, you need to blame George, not me. So as a current goes through any material, it loses some of its energy just from that resistance. And that resistance is what's slowing that electrical movement down. So when you see these old light bulbs, the resistance is actually causing the wire to glow because it's slowing down and there's so much pressure that it's actually causing that glow to occur. We see that in things like our toaster. They use really thin wires with really high resistance, so they give off a lot of heat and actually glow. You can see that in an oven element and also in the lights. So resistors provide high resistance to reduce the amount of current flowing through the circuit. As you add resistors, you decrease the current, but only at that point. You can increase the energy gain from each electron passed through it, and that electrical energy is radiated to the surroundings as heat, light, or sound. So you also can have different cross-sectional areas of the wire. So it gets bigger or smaller, here, smaller, and that actually affects the resistance. So the bigger the wire, the more space that you have for it to move through. Therefore, you're going to have less resistance. So the bigger the area, easier to move through, less resistance. Smaller the area, harder to move through, more resistance. You can also see that your resistance is affected by length of the wire. The longer the wire, the more resistance. The shorter the wire, the least resistance. So for some of you, when you were building your circuits at home, I actually said make your wire shorter. So part of the reason is just because that reduces your resistance really, really quickly. The temperature also makes a difference. The higher the temperature, the greater the resistance. So in something like a toaster, where you want to use that heat energy from the resistance, the hotter it gets, the more resistance it is, and therefore the hotter it will get, the more hot it will get. And so it'll like kind of a circuit going that way, like where it will just build off of itself. It also depends what the material is made from. So is it easy to flow through or hard to flow through? So you can also use this with a dimmer switch, so that changes the resistance as you go through it. Our switches create a break in the circuit, so stops the circuit, prevents the electrons from flowing around. Fuses, I talked about this a little bit before, but a fuse contains a metallic strip that has a really low melting point. So if there's too much current going through, it can actually melt that, and you have to buy a new fuse. Whereas a circuit breaker, which is what you have in the normally in the basement of your house, so it doesn't have to be in the basement, but you'll have a circuit breaker area in your house, and when the circuit breaks, instead of it melting the wire, it actually flips the switch. And so in my house, when I use the hot pot and the kettle at the same time, it will break the circuit and I have to go downstairs, flip the switch and turn one of those off, or it'll just keep breaking. The main difference between a fuse and a circuit breaker is the fuse, you have to go buy a new one. The circuit breaker you can use again and again. If you haven't seen where the circuit breakers are in your house, you should go look. So you can have a variable resistor, so they're known as rheostats, and that adjusts the amount of flow of the current going through your circuit. So you can increase it or decrease it. You've got things like volume knobs, dimmer switches, all of these things work the same way, and they just change the amount of current flowing through. So how is current affected by resistors? The more current flows through a low resistor, less current flows through a high resistor. So the current flow decreases as the resistance increases. The more resistance means the less electrons can flow past that point in 1 second, whereas the voltage will stay the same. Current and voltage have an inverse relationship. Have a direct relationship, so I apologize. So as you increase the voltage, you increase the current. If you decrease the voltage, you decrease the current, assuming everything else stays the same. So the current flow increases as the voltage increases. The more voltage means the stronger push on the electrons, and the more flow or current you will get through your wire. So you can push more electrons past that one point of time, as long as the resistance, of course, stays the same. So there's a formula for Ohm's law. We love formulas. You guys love math. I'm sure this is like the bright part of your day. So our formula for this is V equals, you can't see it because that thing came up, V equals IR. So if you are struggling, because in the video that I show you how to do it, I don't use this triangle method, because as you go into grade 10, They don't teach the triangle method. They don't like the triangle method. I hated it when I taught grade 10 because it made it really hard for you to do the rest of the formulas in grade 10. However, if you hate math, I can show you how to use the triangle method and you can use it for grade 9 and there's absolutely nothing wrong with it. But I have left that as something that I will teach separately and not to the whole group, or I might just do it as a separate video later if lots of people want it. So this, I do a whole worksheet for you on here. It's a little bit long of a video, but it's like doing homework with you. So please watch how to do this. And I know you might after 3 questions think, I don't need to do anymore, but could you just watch them? Speed me up, do it 2 times speed, faster if you want, I don't care. But so that you can see how to do, because that gives a whole bunch of different variations of the different formulas you can have, okay? So this is another one talking about resistors. Watch through, please. And then the types of circuits. So I told you right at the very beginning, we're going to have 2 different types of circuits. We've got our series and our parallel. The series is when you have everything placed in one single loop. So once you hook everything up, if you could grab the wire and lift it up, it would be all in one single loop all the way around. Now don't do that with a homemade circuit because it'll just break. Trust me, I've tried it. It's one path. The more resistors you add, the less current you will have, which means that the light bulbs will actually become less or more dim, less bright. So you increase the resistance and you decrease the current by adding more resistors on there. There's some advantages. So when you add batteries in series, you actually just like keep adding them together. So if you have 2 AA's, you actually would have 1.5 plus 1.5 gives you 3 volts, right? So that's an advantage. And you can turn everything off at once. A disadvantage is if one of the light bulbs breaks, like they used to have this a lot in Christmas lights, one of them breaks and you have 100 lights on your string, you have to go through each one to see which one's broken so that you can fix your current. Also, it dims them. The parallel circuits, on the other hand, parallel can reduce the resistors. Parallel, I don't know where I went to on that one. Parallel has a path, many different paths for it to go through. So the electron is going to choose one path for it to go through, and there's a whole bunch of different ones. As you add bulbs, you actually decrease the resistance. So all the bulbs will burn just as bright. It's just the amount of current is going to change as well. So this is the much more common way for it to be. The voltage is going to be, the voltage drop is going to be the same on each branch. Now the good news is in grade 9, you don't have to be able to calculate all of these small parts. You do have to know how they work, and there will be maybe a little bit more calculation in them, but mostly you just need to know overall how they look. If you decide to continue on in physics, then you will have more chances to calculate these. Personally, I think they're super fun because they're kind of puzzly to calculate, but this year you need to know what they look like. You need to know, be able to find different smaller parts of the math, but not like the huge parts. So advantages for parallel circuit: if you break one pathway, the rest of them still work, no problem there. And then the disadvantage would be that the loads can't be all turned off at once unless you have a switch in a specific location. So you have to be really careful with that. Another video for you to watch. And then the types of circuits and measuring voltage and currents. So you need to have a voltmeter or an ammeter is generally what we use to measure our voltage and our current. So nicely, they're measured. The voltmeter measures volts and the ammeter measures amps. So that's really, really easy. But then you have to be really, really specific as to where you put them in the circuits. So a voltmeter is always in parallel, and it's in parallel so that it can measure the difference between 2 points in the circuit. On the other hand, the ammeter is trying to measure the flow. So you actually have to break your circuit and put the ammeter in as part of the wire. So it goes in series so that it can have the flow go completely through it. Now, if you decide to do it the other way, you'll actually fry both of them. So I'm going to leave that why up to you, and it's in a different video. So you can go and watch that on your own. Thanks, guys. Have a good week.